Today, we're diving into a pretty high-stakes showdown. You've got cutting-edge artificial intelligence on one side, and on the other, one of the most dangerous and sneaky killers lurking in our hospitals. I mean, just think about that for a second. It's a terrifying thought, right? You go into the hospital to get treated for an infection, but the real danger, the biggest threat, is actually your own immune system just going haywire.
And that threat has a name: sepsis. See, it's not the infection itself that does the most damage. It's the body's chaotic, overwhelming response to it. It's like your internal defense system just starts firing in every direction at everything. So, for doctors on the front lines, the biggest challenge has always been trying to figure out which patient is about to spiral into this deadly condition. The signs can be really subtle, and you're always fighting the clock. It's a challenge that has seemed almost impossible, but that might be about to change. All right, so now that we know the challenge, let's start our investigation by really looking at the enemy here. Just how serious is this silent threat? And the stakes here, wow, they are incredibly real. In the study we're digging into today, researchers found that among patients admitted with an infection, a full 8% of them died within just 28 days. Think about that. That's about 1 in every 12 people. This isn't some rare fringe problem. No way. This is a central battle in modern medicine. Okay, so with the stakes this high, doctors haven't exactly been fighting blind. But how have they traditionally tried to figure out who's in the most danger? Let's take a look at the old toolkit. So for years, doctors have relied on these different scoring systems. You've got tools like the SOFA score or early warning scores, and they're helpful for sure, but they have some big limitations. They often just look at a handful of data points, and they really struggle to see the complex, hidden connections between dozens of different lab results and vital signs. They see pieces of the puzzle, but they can't quite see the whole picture. And this right here is the result. According to the research, the predictive power of these tools is, well, it's just not good enough. With an accuracy that can dip as low as 64%, doctors are left with a really dangerous amount of guesswork. They needed a much better way to see the storm brewing before it hit. And this is where our story takes a really cool turn. A totally new kind of investigator shows up. Let's call it the AI detective. So how does this AI actually work? Well, it all starts with this simple little building block called a decision tree. The best way to think of it is like a detective following a single clue. It just asks a series of simple yes or no questions. You know, is the patient's lactate level over a certain number? Yes? Okay, go this way. No, go that way. It's just one simple path. But as you know, one detective with one clue can easily get it wrong. So what if you created a whole squad of detectives? That's the big idea behind something called a random forest. You basically build hundreds of these simple decision trees, you give each one a slightly different piece of the evidence, and then you just let them all vote. And by combining hundreds of these simple votes, you end up with one incredibly accurate final prediction. So, okay, we've got this powerful idea, but how does it actually do in the real world? Well, researchers put it to the test, and this is how their whole investigation went down. The study took place across 3 hospitals in Taiwan, and they looked at 555 patients who were admitted for infections. And just look at the sheer amount of data they collected on every single person. I mean, everything from basic vitals and standard lab tests to these advanced new biomarkers, which are basically specialized lab tests that can measure things like inflammation with incredible precision. And this is really where the AI's power just shines. It sifted through all 219 of those data points for every single patient. It wasn't just looking for one single red flag. It was searching for those subtle combinations, that hidden pattern that points toward danger. And in the end, it narrowed it down to the 30 most important clues. All right, the AI has been trained. The data has been crunched. It is time for the moment of truth. Let's get to the big reveal. This is the ultimate test, right? After all that work, did this new high-tech approach actually do a better job than the old-school methods? Oh, it's not even close. The answer is a massive yes. Okay, so this chart measures predictive accuracy, where a 1.0 is a perfect score. You can see the old, traditional scores, they topped out at about 0.84. But the random forest AI, it scored a 0.96. Now, that's not just a small improvement. In clinical prediction, that is a gigantic leap forward. An accuracy jump that big could mean flagging thousands more at-risk patients way sooner, giving doctors a critical head start to save lives. And this really gets to the heart of why. Quoting directly from this study, the authors say that machine learning models are just better because of their enhanced ability in dealing with multidimensional data. In other words, they can see that whole complex web of connections that other models just completely miss. So the AI detective absolutely proved its case. But what does this actually mean for real-world hospitals and, the patients they're trying to help? Let's talk about the implications. And here's a really important question. The full AI model used some of those advanced, pretty expensive biomarkers we mentioned, tests that aren't available in every single hospital. So, does that mean this powerful tool is out of reach for most places? Well, the researchers tested that exact scenario. They built a second practical AI model that used only the standard, widely available lab tests. And just look at this result. The accuracy barely budged. It dropped just one single percentage point from 96% to 95%. It was almost just as powerful using only everyday data. And this is the most crucial point of all. This isn't some far-off futuristic idea. This study proves that a highly accurate, life-saving tool could be used in hospitals today, using the exact same data they're already collecting on their patients every single day. Being able to give doctors this kind of early warning for sepsis is an absolute game changer. And it really leaves us with an exciting final thought. If AI can help solve the case of this hidden hospital killer, what's the next medical mystery it's going to crack?